so now you're starting to think, what is so special about Matlab? Because it kind of looks like everything that Excel can do. I can drag down a list of numbers. I can just create very long arrays of things, lists of things in Excel as well. Well, the difference is multidimensionality. So to talk about that, let's first create a multidimensional matrix. So one way you can do that, right now, let's just say I want to create a multidimensional matrix full of ones. So MATLAB has an easy way to do that, which is using the function ones. So let's try to create a matrix K that equals to ones that have three rows and two columns. So I get this, which has 3 rows and 2 columns of ones. But the thing is, I can keep going. I can say in third dimension, I want 4 more dimensions, 4 more ones, and then I want it in the fifth dimension. I want 5, 6 dimension, and enter, and I get this giant matrix that has many dimensions. And why it comes out like this is because it's trying to splice up that matrix into human readable format. So it's essentially showing me 2 dimensions at a time. So I go all the way back up. Ooh, boy, this is a long matrix. Yeah, so if I go all the way back up, it's showing me the first 2 dimensions in the first third dimension, the first fourth dimension, the first fifth dimension. And then the next slice of that, the second index for the third dimension. And it's kind of confusing, but basically what this is trying to show me slices and slices and slices of a very multi-dimensional matrix. You might want to ask right now why we're doing this. Well, so let's say K, represents trains. And I can put in the first dimension. Usually you have rows and columns of a table. The rows tell you one piece of information and the column tells you another piece of information. So the row may be the longitude of the train, the column is the latitude, but now you have the opportunity to add many other dimensions of information. So that third dimension could be where the train was made. The fourth dimension is what country is originating in, and the fifth dimension could be what color is the train. So basically you have this way of storing a lot of information in many different dimensions, and all you need to do to look at, say, where all the trains of gray color were made is to refer to a specific subset of this giant matrix. That's starting to get a little bit complicated, so maybe let's talk about how you refer to specific aspects of a matrix. Specific subsets of a matrix. So let's say you have your matrix A here, right? So I want to say maybe look at just the first 3 elements. So that will be done by open curve bracket 1, and then you use this until 3. So this gives me the first 3 elements. Let's say I want to do from 3 until the last one. The nice thing is you don't actually have to know how many there are in this, so you can just say 3 until end. And it's going to give you that back section of the matrix. Cool. So one thing you can also do is to find a matrix, find an element in the matrix. So find, let's say, A, and then we're going to use some of that relational arithmetic. A equals to 4. And so it tells me 3 and 5. And what does that mean? Well, in the third position and in the fifth position, there are the numbers 4. If I want to find A more than 4, it tells me in the 7th, 8th, and 9th position, which is these 3, I have things that are greater than 4. So you can kind of start to see how you can build a giant matrix of all these trains or food types or God knows whatever kind of data you want to store, and you can search through this to find specific kinds of things that are more than so on and less than so on. And you can search within only parts of that matrix. So for example, let's say I have, let's look at the 2-dimensional array of G. So that 1, 2, 3, 4, 5, 6. I only want to look in, let's say, the first column for something that is more than 1. So that first column could be, the price, and maybe the second column is the country, and the third column is the color. Well, I'm only interested in searching price, so I'm just gonna say for find inside G's first column. So to just refer to its first column, I would say open bracket all of its rows. That's what this colon is, basically everything in that dimension, and only the first column. So find this thing, this subset of things that is greater than 1. And it tells me that within that specific subset, within these two, my second element is the one that is greater than 4. If I were to do more than or equal to 1, then it gives me that the first and the second element are more than equals to 1. Okay, I hope that makes sense. If not, just tell me in the comments.